Okay, so we're on page 4. This is lesson C1 and it's about differentiability. So a function is differentiable at a point if one, it is continuous, the function itself, and number 2, its derivative is continuous. So to be differentiable means that the derivative exists. Okay, so here are the directions. Determine if the function is continuous, differentiable, both, or neither. And then there's going to be delta math practice that is similar to this. So we're going to do 2 examples with these directions, and then we'll do a third example that's a little bit different. Okay, so we've got this first one. This is a piecewise function. And first we'll check to see if it is continuous. Okay. Because it can't be differentiable if it's not continuous to begin with. Okay, so first, check continuity. All right, check continuity. All right, so first, so the only place that we're going to have to check, guys, is at 0, because 0 is the number that where this piece leaves off and then this piece picks up. So first we're going to check to see what f of 0 is. Then we're going to check the limit as x approaches 0 from the left. And I'll just leave this blank for now. And then 3, the limit as x approaches 0 from the right. Okay. Alrighty, so f of 0. So I plug 0 in here and I get 0. Okay, so f of 0 is 0. Then the limit as x approaches 0 from the left. Okay, so 0 from the left would be using this piece. Okay, so negative x is going in there. And if you do that limit, you could just plug in 0, and that is 0. So now x is approaching 0 from the right, so I'd be using that piece. And this limit is 0. Okay, so continuous. So the answer is yes to continuity. So the function is continuous at x equals 0. Now check differentiability. Check differentiability. Okay, so guys, in order to do this, what you've got to do is take the derivative. So you'll have f prime of x, and then we're going to take the derivative of each of these parts. So the derivative of negative x is negative 1. So negative 1 for x less than or equal to 0. So I'm just like copying that. And then the derivative of x is 1. Okay, so now we got to check to see if the derivative is also continuous. And if it is, then our answer is continuous and differentiable. Okay, so first we've got to do f prime of 0, then the limit as x approaches 0 from the left, and then the limit as x approaches 0 from the right. Okay, so now I'm using this. So f prime of 0 would be negative 1. So we'd be plugging up into the top. Okay, the limit as x approaches 0 from the left, so I'd be using this top piece, which is negative 1. And if you do the limit of a constant, it's just the constant, so that's negative 1. And then the limit as x approaches 0 from the right, we'd be using that. So we'd be getting 1. So guys, all these 3 numbers don't actually match because we've got negative 1 for the left limit and we've got positive 1 for the right-hand limit. Okay, so the verdict is continuous only. Right, continuous, I'll say, but not differentiable. Okay, so that would be the answer there. Okay, now let's do this one. So we're going to do the same thing. So first, we'll test continuity. So 1, 2, 3. All right, so I need h of 3, and the limit as x approaches 3 from the left. The right. Okay, so h of 3, you'd be plugging into this. So we end up getting 5. 9 minus 12 plus 8 is 5. Okay. Now the limit as x approaches 3 from the left. So I'd be using this top part. And if I plug 3 in, I get 5. Okay. Now x approaches 3 from the right. So we'd be using that. And I plug 3 in, and this is also 5. So h of x is continuous at x equals 3. Now we just need to check differentiability. So I'll go h prime of x equals, all right, so take the derivative of this part. It's 2x minus 4 for x is less than or equal to 3. And then take the derivative of this part, that's just 2 for x is greater than 3. And then I want to do all 3 steps to check continuity on this derivative. So 1, I need h prime of 3. Then I'll do the limit. Okay, so h prime of 3, we'd be plugging into the top. So 6 minus 4, so that's 2. The limit as x approaches 3 from the left, I'll use the top piece. All right, so I plug 3 in, and I get 2. And then the limit as x approaches 3 from the right, I'd be using this, so that's just 2. And so this limit is also 2. All right, so we're, continuity and differentiability are both checking out. So continuous and differentiable. Okay, so both. All right, now we're going to move to the back and do this example. So find b and c that would make f of x differentiable. Okay, so we've got f of x is this piecewise function, and within this function here, we've got this coefficient b, and then this constant term c. And we have to find the values of them that would make this a continuous function. All right, so first, or a differentiable. Okay, so this is f of x. Let's also get an expression or a piecewise equation for f prime. All right, so the derivative of this top piece is 6x plus 4. X is less than or equal to 1. And now in the bottom, so the derivative of this first term is 6x squared. The derivative of this second term is just b, so plus b. And then the derivative of this third term, c, is just 0. Okay, and if you want, guys, you could put you could do this if you want. So if you put x to the first and then x to the 0, then you could kind of see maybe a little bit better where I'm getting that derivative. But that's optional. Okay, now I'm going to do the 3-step continuity test for each of these, and then I'll get some equations that I could use. Okay, so first, f of 1. Second, limit as x approaches 1 from the left. from the right. Okay, so f of 1, I'm going to plug it in up here. So that's 7. And then the limit as x approaches 1 from the left, I'll be using the top piece. And then when we approach 1 from the right, I'll be using that bottom piece. Okay, if I plug 1 in here, I get 7. And if I plug 1 in here, I get 2 plus b plus c. Okay, so guys, if you look at these, all 3 of these things have to be equal. And 7 is, of course, equal to itself. So I could use these 2 limits and set them equal, and that'll give me one of my equations. So I've got 2 plus b plus c equals 7. Now, I have 2 variables, so I'm going to need a second equation. So that's where the differentiability part is going to come in. So we're going to do the same moves for the derivative. So 1. So f prime of 1. Okay, so f prime of 1. So I'll be plugging 1 up here, and I get 10. All right, and then for the limits, for the left-hand limit, I'm going to use the top piece and then the bottom piece for the right-hand limit. Okay, so here I plug 1 in, and I get 10. And here we plug 1 in, and we get 6 plus b. Okay, so for this part here, we have the equation 6 plus b equals 10, because all of these things have to be equal. So that leads us to this. Okay, so you look at your 2 equations. Is there one of them that you could just outright solve for a variable in? And yes, this one. So if you just subtract 6 from both sides, you get b equals 4. And then you plug that in there, and you could get c. So 2 plus 4 plus c is 7. 6 plus c is 7. C is 1. Okay, so b is 4, c is 1, and then that would be a differentiable function.